Hello everyone, we are on the fourth worksheet of chapter 13 and we are going to work out this problem on the test of association using the chi-square distribution. I've already worked this out and explained in details in the lecture PowerPoint, so you may want to go over it if you haven't yet, or please again come to this worksheet after watching those lecture PowerPoints, all right, because that explains a lot of the theory and the formulas, the tables and so on. So I'm assuming that you've already watched it, but here I'm going to go over that problem again because it's in the worksheet and it will give you a second practice. All right, so it was on finding an association between marital status and drinking habit. So a national survey was conducted to obtain information on the alcohol consumption patterns of U.S. adults by marital status. A random sample of 1,772 residents 18 years and older yielded the following data at the 5% significance level. Do the data provide sufficient evidence that an association exists between marital status and alcohol consumption? And they've given us this two-dimensional table. Along the rows we have what's called the marital status, and above the columns are the drinking habits. So the way it works is these values here, this is a frequency table. When we deal with bivariate data, that means data involving two variables at once, then we call it a contingency table, and this is how the frequency table looks like. Contingency table is nothing but a frequency table for bivariate data, and these numbers here inside the table say that this number 67, for instance, would be single people who never drink, who abstain. All right, so 67 was the number of people or number of respondents who said they are single and they never take a drink. Likewise, this number 633 means the number of people who are married and who had taken 1 to 60 drinks per month. All right. So the exercise is to check whether there's an association, whether there's any link, whether there's a relationship between the marital status and the drinking habit. So the first step is to, now this table will be given to you. This is the data table. We have to be given some data. This is the frequency table, but let's look at what is given to us in the question. It says there's total number of respondents were 1772. All right, that was our total sample size. So I'm going to write here 1772 for n. That's going to be the total sample size. In the meantime, the other cells for the totals would be the total number of people who reported they were single. So we have to total that as well. So total number of people who are single would be 67 plus 213 plus 74 would give us a value of 354. Then total number of people who are married, 411 plus 633 plus 129 would be 1173. And then widowed, 143, and then divorced was 102. When we sum them up, it should give us 1772 for the total. In the same way, we have to find the total number of people irrespective of their marital status who said they never take a drink, they abstain from drinking, and that number is 590. Then we have 957 for those who took 1 to 60 up to 60 drinks per month, and then the total number of people who had over 60 drinks would be 225, and we just add up the values column wise. Okay, so we need to know these totals because we need to find the expected frequencies, all right? In our formula for the expected frequencies, we need to use the row totals and the column totals, if you remember the formula. All right, so let's move on. Part A says what is the variable and its possible value. So there are two variables here. All right, we have two variables. This is bivariate data. So the first one is the marital status, and the different values for marital status are single, married, widowed, and divorced. Widowed, and let me lock this, and divorced. Whereas the second variable is the alcohol consumption. And there are three categories of that. So abstain 1 through 60 and over 60. So there are four categories of marital status, and there are three categories for alcohol consumption. Next is to state the hypothesis. We are going to state the hypothesis in a sentence, using a sentence. So the null hypothesis is going to state that marital status and alcohol consumption, marital status and alcohol consumption are independent or they are not associated. Consumption are not associated, and if you're using the word, the term independent, then you just have to say they are independent. For alternate hypothesis, we have to say just the opposite. So marital status and alcohol consumption are associated or they are not independent. There's a relation between the two, some correlation really. Okay, so now we've stated the hypothesis. Now we have to find our expected frequencies. We have the observed frequencies given. We need to find the expected frequencies. The formula for the expected frequencies is E equals R row total multiplied by column total divided by N. So let's fill out the values now. 1772 was the total sample size, which is N, which we are going to use in the denominator of the equation of the formula. But let's list the other values. 1173, 143, I'm just writing it down, 102, and for the column totals it will be 590, 957 and 225. Now to find the first expected frequency for single and abstain, what we have to do is, the formula is E. So take the row total of single, which is 354, multiplied by column total, that is abstain, which is 590, divided by 1772 is our expected frequency. So let's calculate that, and we should come up with a value of 117.9. So here's our O, here's our E, 117.9. For the next one, single and 1 to 60, the row total is still the same. All right, so E equals 354, but this time the column total, the column is different, so 957 divided by 1772 gives us a value of 191.2, right? So let's take something from the middle. Maybe for widowed 1 to 60, it would be 143 for this one. All right, E would be 143 times 957 divided by 1772. You can run this through your calculators to see if we are getting the right values or not. So the way, so that would be, what was it? 77.2. All right, so I'm going to list all the expected values here. Okay, so for 74, they expect, this is OE. So this is 44.9. E is 390.6. Next one is 633.5. Expected is 148.9. Then we have 47.61 for widowed and abstain. We already found this one, widowed and 1 through 60, widowed and over 60 was 18.2. Then for divorced, it's 34, 55.1. And finally, the last one is 13.5. All right, so we have our O and E values. In the next step, all right, oh God, it asks us to perform the hypothesis test. Again, for step 1, state the null and alternate hypothesis. Please see above. That's what I'm going to write. All right, please see above. So just go back and see how we wrote it out. So you should be able to write that. And then the significance level is 5%. So alpha will have a value of 0.05. Let's go down. Now we have to compute the test statistic, all right, using the formula for the chi-squared, which is sigma O minus E whole squared divided by E. So we are going to work through this table step by step. So first I'm going to, in the first column, I'm going to just number the rows or number the cells. So we have 1, 1. This cell I'm going to name as 1, 1, 1, 2, 1, 3, 2, 1, 2, 2. So first row, and then we'll go through the column. Then second row, we'll go through all the columns, third and fourth, like that. All right. So let's name our columns here. All right, so it's the cells. We are look at cell numbers. Then we will list our O's. Then we list our E's. Then we'll do O minus E, and then O minus E whole squared, and then O minus E whole squared divided by E. All right, we are just running through the formula step by step through the table. So let's look at 1, 1. All right, this is going to be the cell. We'll work for the first cell, first column, 1, 2, 1, 3. Then we'll have 2, 1, 2, 2, 2, 3. Then we have 3, 1, 3, 2, 3, 3, 4, 1. 4, 1, 4, 2, 4, 3, and then the last one will be the totals. All right. Now let's just list all our O values. Now what I've done here is I have listed all the observed values and all the E values that we found earlier over here in this table. So we have make sure that you are writing the correct E values corresponding to the observed values. And then in the next two columns, you're going to subtract the 2, 67 minus 117.9, write it here. and then square it. You have to do that for all the rows. And so I've left this for you to complete on your worksheet, but I've given the answer in the final column where we divide O minus E squared by E, which is this column here, right? This column here. All right, this is what we are dividing by. And let me remove that because, all right, and when you sum them up, all right, just a second. All right, and then in the total column here, when you sum up the last column, you should come up with a value of 94.4. And that's your chi-squared sub 0, the test statistic value, all right, based on the data. So now we are going to perform our test using the critical value approach. Again, draw your curve. This is going to be a right-skewed, right-tail test. So, because chi-squared, like your, like some of the other distributions, is a right-skewed curve. So all the hypothesis tests related to chi-squared distributions are going to be right-tail tests. So that means our reject region is going to be on the right-hand side and do not reject region on the left-hand side. So we have to find the critical value in the critical value approach. And since we are testing at alpha equals 0.05, this is going to be here. Okay, we are looking for a chi-squared 0.05, but we have to figure out the df. So let's do that. df is r minus 1 times c minus 1. All right, so df, just a second. Okay, so our df is this formula for association tests. So we have to take our r. So we had 4 rows and 3 columns, right? So df will be 4 minus 1 multiplied by 3 minus 1. Therefore, df equals 3 times 2, which is equal to 6. So df equals 6. So if you look up your table, then you will get a df a chi-squared value. So that's chi-squared, CV is what we are looking for. The chi-squared of 0.05 with df equals 6 will give us a value of 12.592. All right, 12.592. So that's going to be our df, 12.592. Now, given that critical value, let's bring our test statistic now. So chi-squared sub 0 was a huge value, right? 94.4 is greater than 12.592, which is the CV critical value. So it'll fall way, way, way to the right. Okay, somewhere all the way here, which is in the reject region. Again, let me just shade this region here, which is alpha equals 0.05. All right, so if it's greater than your critical value, that means in a right tail test, it's going to fall in the reject region. So let's write that. Falls in reject region. So we are going to end up reject null hypothesis. Now, if you're using the critical value approach, if you're using the p-value approach, then you have to bring your test statistic of chi-squared sub 0 equals 94.4 and find let's say find area to the right, because it's a right tail test. That's where that area is what will be the p-value, but you have to take into consideration the df. So let me just quickly draw a figure here. Again, something similar. And wow, 94.4. Let's, for the time being, assume 94.4 is here. Chi-squared sub 0. So p-value will be, this is our p. It's the area to the right in a right-tailed test. And that area I found using my calculator is, p-value is a very small value, 0. Then there are 4 decimal places, 0.0005. That's what the area is for p. It will be very small because it's a very large chi-squared test statistic value. The probability is very, very small. So what do we do next is, this was the first step to find the area. And the second step, compare p with alpha, right? So is p less than alpha? P is 0.0005. Of course, it's less than 0.05. Therefore, reject null hypothesis. And using both approaches, we see that we've arrived at the same decision. So decision is reject null hypothesis. Reject null hypothesis. And we have to always interpret. So we are going to say that at the 5% significance level, that's how we begin all our interpretation. We have to qualify it using the significance level, because if we use a different significance level, we could have gotten an entirely different result, different decision. At 5% significance level, the data do provide sufficient evidence to conclude that there exists an association between whatever the alternate hypothesis states, all right? Association between marital status and drinking habits and alcohol consumption. Okay, so this is how you're going to go about working on these problems. Again, you will be provided with a table, an empty table on the test, but you have to work your calculations through the table. And once you have your formula, all right, for chi-squared, it should be easy for you to fill the table step by step and get the final chi-squared value, test statistic value. And that's the most important part. That's the most critical part and most involved part in a hypothesis test for associations.